Hey everyone, welcome back to Pine Hollow Auto Diagnostics. We have a big monstrosity in the driveway. It barely fits. It is a 2006 motorhome based on the Ford F53 truck chassis. So the story is the owner takes this thing from Rhode Island down to Florida every year for the winter and then brings it back. So down in Florida last year, he had a problem with his front brakes. He said the pads were worn down, they were grinding on the rotors, so he had a full brake job performed down in Florida. New rotors, new pads, and now, right after he got the brakes done, he said his ABS light came on. And at slow speeds, pulling up to a stop sign, ABS activation. Uh-oh. So he didn't have time to take it to another shop in Florida. He made it back to Rhode Island. He took it to a local shop, and that shop said, hey, your ABS module is bad. It's not putting out the correct voltage to one of the front sensors. So they replaced the whole entire ABS module and hydraulic unit assembly with the pump. Well, guess what? It didn't fix it. I wouldn't think it would, because the problem started right after a front brake job. What does that have to do with the ABS module? But anyways, apparently no one can figure this problem out. So he made an appointment, drove it all the way from Rhode Island to Pennsylvania here. And I told him I'm not really equipped to work on, big trucks, but if it's an electrical problem, we can at least diagnose it, and you'll know exactly what to do to fix it. So let's get into this thing and see what the problem is. Okay, so last night I took this huge motorhome, it's like a coach bus, for a test drive with the scanner plugged in. I didn't record any of that because holding a camera and driving a 20,000 pound rig on the narrow roads around here would not have been a good idea. But we got some good scan data, and let me show you the data that I collected yesterday, and we'll see what we want to do. So here's the full code scan. So the other shop said, why did they replace this ABS module? Because of some circuit fault to the sensor. Okay. Then with the replacement module, junkyard unit, obviously they're not available new, they said it wouldn't even communicate. So, okay. I scanned the whole truck for codes. There are only 3 modules. We have ABS, PCM, and instrument cluster. That's it. And look, in ABS, we had front left wheel speed sensor input circuit fault, front left wheel speed sensor input signal lost, and right front wheel speed sensor input signal lost. Turns out the front left sensor was completely unplugged, because the other shop did that to prevent any false, unwanted ABS activation. So plug the sensor in, took it for another test drive. Now, clear the codes. No codes came back, but occasionally when slowing down from, cruising speed down to a stop below 10 to 5 miles an hour, the brake pedal would be bzz, 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 and then you'd come to a stop. So unwanted ABS activation. No codes were set. So then I graphed the wheel speeds here. So in this case, the scanner gave me 5 speed data PIDs. So left front, left rear, rear differential wheel speed, right front, and right rear. If you notice, left rear and right rear, they're about half of the other 3. So in this case, this is actually a 3-channel ABS system. So these left rear and right rear wheel speeds, I think they're calculated somehow, so don't pay attention to those. We're worried about this one, left front, rear differential, and right front. The speed, all the sensors record speed and they agree. However, I noticed that the left front looked a little bit choppy here. So see how steady this rise in speed is right here and right here? So this is the right front, this is the rear differential. This one's kind of like bumpy. So again, putting all of the pieces of the puzzle together, what could have happened during this brake job on the front wheels? tone wheel damage or sensor damage, but the sensor, the circuit's good. It's not fussing about that. It's recording the speed mostly correctly, but it seems like it's glitching a little bit. That's a classic tone ring fault. So I looked up some part diagrams, like where is this tone ring? How do you need to take it off to replace the rotors? We'll get into that. But without taking anything apart, how do we 100% determine if it is a tone wheel failure? If one tooth is damaged or something. Well, we have to use the oscilloscope. If we can't see it directly, you want to measure the signals, see what the computer's seeing, what the module's seeing. So here is the wiring diagram. Let's take a look at that. Okay, so from all data I printed out the wiring diagram for the ABS control module. Pretty simple, it's 2006, so it's not super fancy. 3 wheel speed sensor inputs. Left front, right front, and rear axle. That's right on the differential. So 2 wire sensors, and you would think that it's just a variable reluctance type with a sine wave. But be careful. Not true in this case. If we look up the code description for the C1233, signal lost, what do they say? How do we check these sensors? Well, apparently, you disconnect the sensor, and they say connect a fused jumper wire on this tan orange wire, and then on the second one connect it to an ammeter. That's very interesting. So they tell you, as you slowly spin the wheel, does the automotive meter switch between 6 and 14 milliamps? So these sensors are digital type sensors, and the circuit in here, it basically changes the resistance from low to high, and the current flowing through the circuit changes between 6 to 14 milliamps. So it looks like this is a constant feed, while this is the signal and the return on one wire. So I want to scope both wires on the left front wheel, and we compare it to the right front wheel without taking anything apart. We don't know what the actual voltages are here, but we'll find out because we have hopefully at least one known good. And we'll measure, compare apples to apples. So on the rear wheel axle speed output, do the same thing. You might ask, can you measure the resistance of the sensor? Well, let's see. Check the wheel speed sensor circuits for an open. Let me find where they're checking resistances of these sensors. So to find this information, you're not going to find it in component descriptions. You have to go to the trouble codes and go to these pinpoint tests. So for example, if we go to code C1155, wheel speed input circuit failure, that's basically if you have it disconnected, open, shorted sensors, they tell you to check the actual resistance for shorted wheel speed sensor circuits. Resistance between the suspected front wheel speed sensor pins, harness side. Check the ABS module output. Are the voltages greater than 10 volts? So basically, across these two pins, it looks like we should have 10 volts on the harness side. Harness side. Measure the resistance between rear wheel speed sensor pins. Is there any continuity? So I don't think they're checking the actual sensor itself. Anyways, let's go to the truck. hook up the oscilloscope, turn the key on, spin the wheel, and see if we have a nice train of digital pulses. We got the scope hooked up to all 4 wires on those sensors. Let's also log in with the scanner. Look, only 3 modules, so we'll just scan them all. We'll go into ABS. Front left wheel speed sensor circuit input. Fault, that's because we had it unplugged. So they're all 3 miles per hour. Let's spin the left front wheel. I'll have to spin it a little faster than that. But can we see a signal? So what I don't understand is both the red and the yellow channels here. So on the front left, this is channel 2 red, right front, I'm sorry, this is channel 1 blue, this is channel 2 red, and then on the right front, the feed, channel 3 green, and the signal is channel 4 yellow. Let me double check that I have those right, because some stuff's not making sense. There's nothing going up to 10 volts. So the description operation here, this plus and minus, really doesn't make sense to me at the moment. So on the left front wheel, the only signal that I see is on the blue channel, which is the feed, and apparently the red and the yellow are grounds. Not like the OEM service info said, but this is a stripped chassis. This is not an F53, built truck. So let me activate filtering here, and here's our waveform for the left front wheel. And it looks fine. I don't see any missing teeth. We can bump that up. We can even decrease the filtering. There you go. Let's spin the other wheel and see what the amplitude is. Maybe it's just a weak amplitude. So with the ground connected, the red and the yellow stay exactly at 0. So those must be sensor grounds, just pure grounds. And then the positive is the signal. And that's only going up to 1.4 volts on both the left and the right side. And that's what the shop said, that the module wasn't putting out enough voltage, and that's why they condemned the module. So, are we dealing with some wiring? Like, is it shorted to ground? We can do some quick resistance checks just from these wires to ground. That voltage is elevated and there's a signal on it, but shouldn't it be 10 volts instead of like close to 2? Alright, we got the trusty ohm meter out. Let's do some measurements on these wires. So we conveniently have all 4 wires back probed on the harness side at these front sensors. So according to the data that we collected, I think the red and the yellow channels, these things are just ground. Okay, let's verify that. So the red channel, measuring the resistance from here to chassis ground, about 3 ohms. So that'll be the red channel on the left front. So this is 3 ohms. Check that. Now let's connect the yellow lead to here. Same thing, 3 ohms. Wrote that down. Now, let's check the resistance on those signal wires. So module's off, truck is off. Is this shorted to ground? Why do we have a voltage less than expected? also 3 ohms. 3.2. So 3.2 ohms. So we're measuring from here to ground. Is it being grounded through the module? I don't know. Let's measure the last one, which is our... No, I'm sorry. Let's keep track of this. So disregard the last measurement. The blue to ground. Infinity. Okay, that's reasonable. The green to ground. Also infinity. Let's just double check. Red to ground. 3 ohms, yes. Yellow to ground. 3 ohms, yes. So those are grounds, and this is infinity ohms. This is infinity ohms, so we don't have any wires rubbed through touching to ground, pulling this module signal to ground. Okay. Now my question is, at the ABS control module, keep in mind this is the replacement module. We could try plugging in the original one and see what happens to these signals. So the original module is right here, the whole piece, and so we got the 2 big plugs there, 1 connection there. That's probably the main power and ground. We can suspend this, plug this into the truck, and see if anything changes, because I don't see any wiring problems at the moment. So we got the original module ratchet strapped to and plugged into the truck. Let's plug the scope back in, turn the key on, see if the voltages are any different. If we spin the left front wheel and the right front wheel, are the signals getting crossed? What the heck is going on? So as I suspected, the voltages did not go up past that 1.4 mark. And if we plug in, let's try plugging in the this sensor right here, the left front. So it pulls the blue down. We see a signal on there. Now the scale is okay. Well, let's unplug this one. Plug the other side in. Okay. Okay, now the green is pulled down. Let's see what happens on the screen. We spin this wheel. Get a much nicer signal, don't we? Let's plug both of them in and then spin that wheel. Alright guys, check it out. There is a difference. Both sensors are plugged in. We're spinning the right front wheel. Just the green trace is responding. Now we spin the left front wheel. Perfect. Here's where the real problem is. The left front signal is extremely weak compared to the right front. See the amplitude difference? This is the same scale. They're both on 10 volt scales. The green one, about 500 millivolts. The blue one, yeah, no wonder it thinks the left front's locking up. Look at the amplitude. 100 millivolts, so 5 times less signal. So this is the money shot right here. We're dealing with a sensor or sensor gap issue on the left front wheel. Now we can play some Swaptronics. We can move the sensors around. They're not too hard to move around. And then we're almost done. Alright, let's repeat the experiment with the module that's installed on the truck. I just plugged it back in. And roll the scope. Alright, let's spin the left front. That's okay. Weak. Okay, so the modules seem to be identical. I just had a scope ground problem. So that's good news. Now we have to figure out why this amplitude is so small. So now we're going to focus on the sensors and the sensor air gap. So 2.6 kilo ohms I'm measuring from here to here, from the plus to the minus. What if we reverse the leads? Exact same. So 2.6 kilo ohms on the left side. Let's measure the right side. Okay, same exact measurement on the right side, 2.67 kilo ohms. And that's to be expected because both sensors pulled the signal down appropriately. So now, the last remaining piece of the puzzle here is the air gap between the sensor and the reluctor ring. Let's take a close visual inspection on how that works. So I used an endoscope to take a picture of the sensor to tone ring clearance. The sensor looks all kind of rusty and covered in crap. So even though the resistance of the sensor could be good, what about whatever circuit in there is changing the resistance when the teeth go by? That could still be bad. We could be dealing with a bad ABS sensor still. Let's take a picture of the right front sensor. And on this design, on the two-wheel drive, you can actually see the tone ring. It's pressed onto the hub. You may be able to see that. Yep, there's the tone ring, and the sensor is basically on the side there looking at the tone ring. Alright, so on the right front wheel, the sensor doesn't look much different. It's covered in little rust particles and little shavings and whatever. And the gap it's very close to the reluctor, so I don't see any big difference. I do want to blow these off to get a more accurate view of the gap. There's a little friend. And then we'll see, should we swap these around or is there any other issue? So use compressed air to blow all the crap off the sensors. I want to get an accurate picture of this gap. So look at this one. The right front, the one that had a stronger signal, the reluctor wheel is almost touching the sensor, right? That looks great. Then I took a picture of the other sensor. Look at the giant gap on the left front wheel. So right front's good, left front, this thing looks like a corroded chunk of crap, and look at the gap. It's significantly bigger than the right front wheel. So we need a new ABS sensor. I would recommend both because they're both the same age, and you know, if one goes, the other one's not too far behind. But you see that it just rusted away, like the tip of the sensor rusted away. The gap became too big, and obviously the sensor's too small, and that's causing the unwanted ABS activation, and that's an issue. So there was nothing wrong with the brake job per se, but why did this happen right after a brake job? Well, things were you know, moved around and bumped around, and a little chunk of rust fell off, and now you have a weak signal. So not necessarily the shop's fault, just the way it is. And there's nothing wrong with the ABS module. So that's where we are. I'm going to see if we can find a replacement sensor. They shouldn't be too hard to replace. I'm going to try to get the old one out. That might be a battle if it's all corroded in there, but that's what it'll take to fix this RV.